Hello, today we're going to continue with rotational motion with a example problem taken from a physics textbook, and the authors consider this to be one of the more difficult problems. So the first thing I would do would be to read the problem and write down all the given information and draw a little sketch to help you visualize what's going on here. And then I would also convert the given information to SI units, get it in a consistent unit system so you don't make a mistake with the units. So here it says a belt runs on a wheel of radius 44 centimeters. So I would write that down. And 44 centimeters is 0.44 meters. And then it says during the time the wheel takes to coast uniformly to rest from an initial speed of 1.8 revolutions per second, 29.5 meters of belt passes over the wheel. So here we have quite a lot of information that the final speed is 0 because it says it comes to rest. The initial speed was 1.8 revolutions per second, and then I would convert that to radians per second, and there's 2 pi radians per revolution. So that turns out to be 11.3 radians per second. And then it said 29.5 meters of belt passes over the wheel. So we can use the symbol S for that. And then they want to know the deceleration, which is alpha, the angular acceleration. That's a question mark. And then they want to know the number of revolutions it makes while stopping. So that's a question mark. So then I would draw a little sketch of it. So you got a wheel, and then 29.5 meters of belt pass over it, or that would be equivalent to this wheel rolling over a distance of 29.5. So then you could calculate the number of revolutions from that. That's one way to do this problem. So if I have time, I'll do the problem 2 ways here. So theta is given by S over R. So that's going to be your 29.5 meters divided by the radius of 0.44 meters. And that's going to be 67 radians. And then we could get this answer immediately because there's, in 1 revolution, there's 2 pi radians. and that works out to be 11 revolutions. So I've looked at the formulas, and I don't think it's possible to find the deceleration or alpha first. I think you have to find the number of revolutions first. So now we just have to determine alpha. So if you look at all your formulas, I get your formula sheet in front of you, and then what I see is this formula can be solved for alpha because you know everything else. You know the final velocity, you know the initial velocity or speed, and you know the number of revolutions. So the final velocity was 0. The initial was 11.3 radians per second squared. Then you're looking for alpha, and theta was 67 radians. In the SI system. So then you just have to solve for alpha here. So you can move, square this, square the 11, and so it's going to become negative 11.3 radian per second. And then you'd have to divide by 2 and 67. And then you might notice, see, you're going to get radians squared and seconds squared. So you're going to have the radian in the denominator cancel 1 in the numerator. And this is going to turn out to be about 0.90 negative radian per second squared. So they might ask for the deceleration in revolutions per second. So in that case, you'd have to multiply in 1 revolution, multiply by this 1 revolution per 2 pi radian. So that works out to be about 0.14 revolutions per second squared, negative. So that's one way to work the problem. So let me work it another way on the next page. Okay, so we found theta already. That was 67 radians. And then in this method, you can solve for the time first. You might recall that the average was the final velocity plus the initial velocity divided by 2. So you know theta was 67 radians. The final was 0, and the initial was about 11 radians per second. So you can solve this for time. So you get the time is about 12.2 seconds. So just when you're working physics problems, if you get a negative time, then you probably did something wrong. So that's a good indication here we're on the right track, is we got a positive time. So then you can solve this equation. Well, I made a mistake here on the equation. Let me. So this was 0. This was about 11.3 radians per second. And you're looking for alpha. And now you know the time is 12.2 seconds. So again, alpha is going to be a negative 0.90. And this was in seconds. So when you solve this equation, you'd be dividing the 11.3 radians per second by 12.2 seconds. So you get the second squared. So, and then you could convert this again to revolutions if you wanted to. So this was in 1 revolution divided by 2 pi radians. And that turned out to be about 11 revolutions. And then the same conversion factor here, 1 revolution per 2 pi radians. So you get alpha, again, would be about negative 0.14 revolutions per second squared.